The isotopes of chlorine with mass number 35 and 37 exist in the ratio if its average atomic mass is 35.5. Average atomic mass is 35.5, which is equals to 35 is a mass number into X plus 37 into Y by X plus Y. So this is equals to 35.5 into X plus 35.5 into Y is equals to 35 X plus 37 Y, right? Then this is equals to, here we have 35.5, here 35. If you bring 35 left side, then this becomes 0.5x is equals to, and 35.5 you have to bring right side, then 37 minus 35.5, that is equals to 1.5x. Then x is equals to 3y. X by y is equals to 3 by 1. 3:1 is the answer. Atomic mass of boron is 10.81. It has two isotopes, namely 5 boron 11 and 5 boron X, with the relative abundance of 80% and 20% respectively. Then value of X is asking. A simple average atomic weight is given here, that is 10.81. So here you can write 10.81, which is equals to, here he said first boron, that is 11 into 80% he said, so 0.8 plus second one is X into 20% he said, that is 0.2, right? Now from this we can get X value, that is, simplify this, then we'll get X is equals to 10.05. First one is the answer. Next, the number of atoms present in 8 grams of ozone is 8 grams of ozone. So here is asking number of atoms. It is very simple, that is 1 mole of O3 weight is 48 grams. So 48 grams contains 3 atoms, whereas 8 grams contains how many? So cross multiplication, then X is equals to 3 into 8 by 48 into Avogadro number. So that is 24. X is equals to, here I'll write 24 by 48 into Avogadro number. 24 ones are 24 twos are, that is nothing but Na by 2. D is the answer. Next, which of the following is a reasonable value for the number of atoms in 1 gram of helium is asking. So generally 4 grams of helium contains Avogadro number 6.023 into 10 to the power 23. And here he is asking for 1 gram, cross multiplication again. So here X is equals to 6.023 into 10 to the power 23 by 4 grams. Right? By solving this, we'll get 1.5 into 10 to the power 23. Next, the dot at the end of sentence has a mass of about 1 microgram. Assuming that the black stuff is carbon, number of carbon atoms present in it, right? So here it is very simple. Microgram, he said microgram is nothing but 10 to the power 6. So here is asking number of carbon atoms. number of carbon atoms formula is number of moles into Avogadro number. So number of moles, how to find out? Number of moles is equals to, we have weight by molecular weight, right? Here your atom is asking atomic weight you have to take. So your weight is given microgram. Microgram is nothing but 10 to the power minus 6 by, and your atomic weight of carbon is 12 into, that's it. So number of atoms is asking. So number of atoms we have to multiply with Avogadro number into 10 to the power 23, right? Then we'll get number of atoms is equals to 5 into 10 to the power 16. You have to simplify this. First one is the answer. Next, 1 gram molecule of oxygen gas is 1 gram molecule of oxygen gas occupies 22.4 liters. So R will come. At the same time, 1 gram mole of oxygen is equals to 1 mole of oxygen. Q also will come. Gram molecular volume of hydrogen is 1 mole of hydrogen. The same time, it is also occupying 22.4 liters PR. 44 grams of carbon dioxide. 44 grams of carbon dioxide is nothing but 1 mole of hydrogen is not applicable, 1 mole of oxygen is also not applicable. 22.4 liters at STP, 44 grams. Yes, 44, 1 mole of oxygen is also applicable because oxygen is there now, Q, and R is also applicable. Next, here it is 3 atoms are there, so 3 number of atoms, S is also possible. 18 grams of water. 18 grams of water contains, water is H2O, right? So H2 molecule, right? P is applicable because P is also applicable. Here hydrogen H2 is present. The same time 1 mole of oxygen, no, it is molecule, but in H2O there is a oxygen atom is present. 22.4 liters at STP, so not correct. And next 3 nitrogen, Avogadro number of atoms, H2O, yes, 3 is possible, PS is correct. Next, if the relative atomic mass of oxygen is 64 units, molecular mass of CO becomes. So here he said that relative atomic mass is 64. Relative atomic mass is equals to 64, right? That is for oxygen. Relative mass of oxygen is 64. So what is the molecular mass of CO is asking. So generally oxygen atomic weight is 16 into 4 is 16 4 is 64. Is it clear? Whereas carbon monoxide is asking, carbon monoxide is 28 into 4, that is equals to 112. So 112 is the answer. 7 grams of nitrogen occupies a volume of 5 liters under certain conditions. Under the same conditions, 1 mole of a gas having molecular weight 56 occupies a volume of 7 grams. So I'll convert into moles. 7 by 28 grams occupies 5 liters. Then see, 7 by 28 is nothing but 1 by 4. Simply 0.25. Should I write? 0.25 moles occupies 5 grams. Then here he is asking, under the same conditions, 1 mole of gas having molecular weight 56 occupies, yes, 1 mole occupies how much? So X is equals to cross multiplication 5 by 0.25. So that is equals to 2, right? 5 by X, that is nothing, 0.5 will get. So X is equals to 5 by 0.25. Okay, 20. 20 liters. Next, there are as many nodes as number of oxygen atoms in 24.8 grams of Na2S2O3.5H2O. Molecular weight is given 248. A node counting machine counts 48 million nodes per day. Number of days taken to count these nodes is 10 to the power x. So here number of oxygen atoms formula is number of oxygen atoms is equals to number of moles into Avogadro number. Number of moles is equals to given weight by 24.8 is given weight, 248 is the molecular weight into Avogadro number into number of oxygen atoms. How many here? 3 plus 5, that is 8 oxygen atoms are present. So this is equals to 0.8 Avogadro number. And he said that 48 million nodes per day, he said. That means 48 into 10 to the power 6. This is for one day. Then 0.8 into Avogadro number is equals to how many? X. So cross multiplication again. X is equals to 0.8 into 6.023 into 10 to the power 23 by 48 into 10 to the power 6. Right? By simplifying this, we'll get 10 to the power 16. So x is equals to 16.